Recent congressional hearings have brought a fringe topic to the center of public discourse. Military whistleblowers have testified under oath about unidentified anomalous phenomena, fueling intense speculation about the possibility of extraterrestrial contact. Prominent scientific voices, including astrophysicist Neil deGrasse Tyson, acknowledge that the mathematical probability of intelligent life in the universe makes the search a valid scientific endeavor, moving the conversation away from tabloid rumors. Former President Barack Obama publicly confirmed the existence of footage showing aerial objects whose flight patterns defy current aeronautical understanding. The volume of civilian reports and declassified military videos is massive. Yet within this deluge of sensory information, the scientific community struggles to isolate rigorous, testable data. Looking to the sky for answers is an enduring human reflex. When confronted with the vastness of the cosmos and our own vulnerability, we consistently construct elaborate narratives to make sense of the unknown. The ancient astronaut hypothesis proposes that extraterrestrial beings visited Earth in antiquity, acting as a mother culture for early civilization. It thrives in the documentary gaps of archaeological records. Proponents of this idea often cite controversial interpretations of ancient Sumerian texts, claiming beings called the Anunnaki descended from the heavens to genetically engineer early hominids into a labor force. Ancient petroglyphs, like those found near Hopi settlements, are frequently recontextualized by theorists. Figures representing complex indigenous spiritual beliefs are literalized as astronauts wearing space helmets. The vocabulary changes, but the underlying impulse persists. Contemporary thinkers debate simulation theory, suggesting our universe is a computational construct designed by technologically mature post-humans, replacing ancient deities with modern programmers. A profound desire for cosmic companionship drives these theories. To move from mythology to reality, we must rely on strict analytical frameworks that prioritize physical evidence over narrative appeal. The scientific method approaches anomalies using Occam's razor, the principle that the explanation requiring the fewest assumptions is usually correct. In antiquity, the rise of human agriculture and architecture can be fully documented through natural social evolution. Invoking extraterrestrial intervention adds an unnecessary layer of complexity. Similarly, discovering biological patterns that resemble computer error-correcting codes does not prove a simulated reality. These structural similarities are natural outcomes of physics and genetics. The material artifacts left by early civilizations provide a clear, chronological record of human capability and technological progression. To address current atmospheric anomalies with that same rigor, NASA established the Unidentified Anomalous Phenomena Independent Study to evaluate sightings from a purely scientific perspective. Their initial directive involves gathering and standardizing decades of fragmented data previously collected by various civilian government entities. This effort expands to include high-quality observational records held by commercial aviation companies and nonprofit organizations. By developing strict air traffic management protocols, analysts systematically filter out sensor glitches, weather events, and known aircraft. The primary objective is to establish basic physical constraints for these objects and determine any tangible risks to the national airspace. Serious investigation requires exhaustion. Researchers must methodically rule out every terrestrial explanation before entertaining the possibility of a non-human origin. While atmospheric anomalies command public attention, the most robust search for extraterrestrial intelligence is directed outward, scanning distant star systems. Space-based observatories operate beyond the distortion of Earth's atmosphere, continuously collecting deep space telemetry for the NASA Exoplanet Archive. During a transit survey, the instrument records a minute, predictable dip in a star's light curve as a planet passes in front. Spectrometers then measure absorbed wavelengths, identifying specific gases like oxygen or methane, potential markers of biological activity. The search for life depends on detecting precise chemical imbalances across light years of space, a process defined by rigorous measurement rather than visual speculation. Given the billions of potentially habitable worlds mapped in our galaxy alone, the statistical probability that life emerged elsewhere remains high. Yet here on Earth, structures often claimed as evidence of paleocontact stand instead as testaments to the capabilities of early humans. The Great Pyramids required advanced terrestrial mathematics and decades of organized labor. The moai of Easter Island demonstrate how isolated societies developed highly specialized engineering techniques to carve and transport massive stone blocks using entirely local resources. Recognizing our own historical achievements allows us to face the cosmos objectively. We have transitioned from projecting mythology onto the stars to measuring their exact chemical compositions. Today, networks of terrestrial arrays and orbital telescopes continuously monitor the electromagnetic spectrum. By systematically filtering out localized sensor errors, known aircraft, and human-made interference, we are left with the vast, quiet reality of the local universe. As we refine our instruments and stare deeper into these star fields, the probability of intercepting an authentic signature increases. When the data finally reveals an anomaly that cannot be explained by natural physics, we will have to decide how to answer.